First thing we need to do is we need to define perpendicular bisector and equidistant. Now, we've talked about those before a little bit, right? So we've talked about equidistant, right? So let me talk about a perpendicular bisector. A perpendicular bisector is a line, ray, or segment that is perpendicular. This is the symbol for perpendicular. It's an upside down capital T. Right? Have you seen that before? Perpendicular to the side of a triangle at the midpoint of the side. Okay, so a perpendicular bisector would look like this. If I draw a vertical line like that, and if it intersects at a right angle, and it makes these two segments from here to the middle and here to here congruent, meaning it's at the midpoint, that makes this line in the middle the perpendicular bisector. Okay, and we've talked about equidistant before. Again, what does equidistant mean? Distance is equal. Yeah? All right, so theorem. Perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the end points of the segment. So that highlighted part is the part that you need to fill in on yours. It is equidistant from the ends or the end points of a segment. Okay, so in this drawing, XY is perpendicular to AB. That's why they have this right angle marked there. And YA is congruent to YB. That's why I have these markings there. Our conclusion then is that XA is congruent to XB. So if I were to take that perpendicular bisector back off the page, it has created an isosceles triangle, hasn't it? By making two sides congruent. Okay. The converse of the perpendicular bisector, so make sure you have everything highlighted there on your notes there, says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So if XA and XB are congruent, then we can conclude that the perpendicular bisector is perpendicular and that these two segments are congruent. Okay, I think that's all I got to cover. So what does that mean as far as us solving problems? Well, that's what we're getting into now. So, we ready for number one? Yeah? All right, do I have a perpendicular bisector? It is perpendicular, yes. And these two are congruent, which means it's a perpendicular bisector. It's cutting it in half. So that means This side is congruent to this side. So what is MN going to equal? 2.6. Easy peasy. Okay. Let's see. I have an isosceles triangle, correct? This is perpendicular, so what does that tell me about this? That's going to be congruent to it. So BD is also going to equal 12. Yep. That base gets cut exactly in half. All right, solve for x first, then find UT. So, again, perpendicular, and these two are congruent. So what does that mean about these two sides? They're congruent because we have an isosceles triangle. So I set 3x plus 9 equal to 7x minus 17. Subtract my 3x. 9 equals, what, 4x minus 17. Add 17. 9 plus 17 is what? 26. Divide by 4. What's 26 divided by 4? I'm getting an ugly answer, aren't I? Well, I guess we do what we do. 26 over 4 is 13 over 2. It's a fraction. It's ugly. I don't think there's fractions on your homework, but there we go. And then find UT. So that would be 3 times this plus 9, right? Let me show you how to do it on your calculator. Don't be afraid of fractions because you can do them on your calculator. I've shown you your fraction button before, right? Okay, let's use our fraction button. So 3 parentheses, 13 fraction button 2. 3 times 13 over 2 plus 9 is 28.5. But we don't like the mixed numbers there, so I'm going to hit second fraction button again. And UT is 57 over 2. It's ugly, but that's it. So? Yes?
Can't make it a decimal?
Don't go to decimal. The reason is because many decimals, you end up having to round. And as soon as you round something, you are not 100% accurate. It's not an exact answer anymore. So avoid decimals. I don't think you have any fractions on your homework. But if you do, use the fraction button. That's what it's there for. Okay? All right. Let's see. You try 4, 5, and 6. See what you get there. Did you get x equals 4 for number 4?
Yeah. Mm-hmm.
Okay, then find dA. So 5 times 4 is 20, plus 12 is 32. Five times 4 plus 12. Okay, BC is, I'll write it this way, 4x plus 1. So let's see, 2x plus 5 equals 4x plus 1. I just need to solve for x. I'm going to subtract 2x. Subtract 1. 4 equals 2x. Divide by 2. And what does x equal? 2. All right, let's see what we've got. AD is 6x plus 3. And then BC, I'm sorry, this is 6x plus 3, right? This is 3x plus 21. What am I going to do here? Well, this is 6x plus 3, right? And this is 3x plus 21. I don't know what I can do with this. Do you know what I can do with this? What can I do?
You can add 6x plus 3 plus x to 1 equal a.
Except that they're not giving me angle measures. Angle measures add to 180. If I set this equal to this, everything's going to cancel out. If I set this equal to this, everything is going to cancel out, right? 3x plus 21, and BC is 6x plus 3. I don't think we can do anything with that one. We'll skip it. Doesn't give me enough information, does it? Okay. Ah! Where's my backside? Here we go. Angle bisector. What's an angle bisector? A ray, segment, or line that divides an angle into two adjacent congruent angles. Yeah? We'll just do one at a time. So, the angle bisector theorem says if a point is on the angle bisector of an angle, then it is equidistant. So if I have an angle bisector and I know that these two angles are congruent, this point is going to be the exact same distance to that side of the angle as it is from that side. So in other words, those two are congruent. Okay. And here our conclusion is AC is congruent to BC. So again, equidistant from the sides of the angles. You have this all written down? Okay. The converse says if a point is on the interior of an angle and it's equidistant from both sides, then it's on the bisector. So I can conclude then that angle APC is congruent to angle CPB or BCP or BPC, sorry. Okay. All right. So, in number 1, we have marked angles being congruent. What do we know about congruent angles there? That means that this is what? A bisector, which means that these two sides are congruent. So what is BC? 7.2. Okay. All right. Do I have an angle bisector in the second problem? I do, because you see that this and this are marked congruent. If these are marked congruent, that means this is a bisector, so I can conclude that those two are congruent. So let's see. EFG, that's the whole thing, right? That's the big angle, is equal to 50. So if these two are the same, what's EFH? 25 degrees. Easy peasy. Okay, number 3. Again, I have these marked. What does that mean about those two angles? They equal each other. So 3A plus 20 is equal to 2A plus 26. Whoops. Subtract 2A. They're changing letters on me. I'm going to start writing X's, I swear. A plus 20 equals 26. So A equals 6. Then what does it ask me to do? Find JKM. That's this guy right here. So 3 times 6 plus 20 means that the measure of angle JKM is what? 3 times 6 is 18 plus 20 is 38 what? Degrees. Pretty easy, yeah? Okay, you try the bottom 3, see what you can do with them. Okay, so number 4 is the hardest one of these 3. They give me EFG, which is the whole thing, right? Then they tell me GFH, which is just this part, right? Just this guy, is 4x plus 3. Well, if this one is 4x plus 3, what is this guy? 4x plus 3. And those two together will equal the big one. So I could say 4x plus 3 plus 4x plus 3 equal 2x plus 17. Does that make sense? Okay. So 4x and 4x gives me 8x plus 6 equals 2x plus 17. So I'm going to subtract 2x. So 6x plus 6 equals 17. Subtract 6. 6x equals 11. Yeah? And again, we have an ugly decimal, right? So x equals 11 over 6. Okay. So I'm going to go ahead and, whoops, not that one, use my calculator to do the fractions. So EFG, that's the big one, that's 2 times 11 over 6 plus 17. Change it to an improper fraction. And EFG is 62 over 3 degrees. It's ugly, but it is what it is. Okay? All right, so we are running low on time. We have 1 minute left. Those two should be pretty easy, but you should know enough to do your homework. So I'm going to go ahead and stop right there and pass out your homework. Happy studying.